All right, let's figure out what is this thing standard deviation of the slope? What is that? Well, we already talked about standard deviation. You know that. The average distance from the mean. On average, how far away is all these things from the mean? Okay. Well, look here. Here's what's happening. So we've got this situation. A standard deviation of the slope occurs because you know we know that the slope of your sample, if you went out and you collected a whole bunch of data on trees and their volumes in the forest, okay, and I go and out and I get a bunch of examples of the slope or the trees and their volume in the forest. Well, is your equation of the line going to come out exactly as the equation of my line? Well, that answer is no, because your sample is a little different than my sample. Your sample is different than me because of sampling variability just from sample to sample. Okay, well, how much are our slopes going to kind of change from sample to sample and be reasonable? How much is like, oh, holy moly, what the heck is going on with your data? That is a way different slope than all the rest of us. So, something happening in your area of the forest? Is there pollution making things grow at a much slower rate or having a whole lot less volume for the particular height? Whatever. So we want to know what's the variability? How much does the slope normally vary? Okay, and what's way weird? All right, so here we go. So what happens is, so here's an example. We've got this here where we have the age and weight. Okay, and I don't know, these are pounds, I guess, in heights. I don't know what these are. Uh, these have got to be different things like um, inches and they've got to be some other unit than are customary. They've got to be some kind of metric, something or other. If you look at those numbers, okay. But whatever it is, okay. So if we put our line through there, okay. So you just kind of draw your line of best fits. So there, that looks like it's about the average and where that line might go. Okay. So now, one thing that's interesting that we're going to find is that the mean of the x value, the average of the x values, and then the average of the y values is always going to be a point that is on the line. So that means that my value is going to be the mean of the x's. If I was to figure out where that is, and the mean of the y's is probably something about right there. Okay, so if you go and you collect data and you get a different line. Okay, so let's say you go get a different line and yours looks about like that. Well, your mean point is going to be pretty close to mine. So we're going to be pretty close to having that same center. And what ends up happening is people may get different slopes, but they generally kind of toggle around that same central location. They're not perfect, but they're kind of just going along, generally focusing in on that mean area where those different lines are happening. Okay, well, that one was kind of far off. But anyway, so that's what's happening. And so then we have this variability in the slopes. The slopes are varying from sample to sample. So we're going to discuss, well, how much is a normal amount to vary? Or, if somebody got this slope right here, then I'm going to say, holy moly, you're growing way faster. You're getting a whole lot heavier weight for that particular age than the everybody else's. So something's happening there. Okay. So that's what's going on. Now I have a picture of some ones that I've drawn here. There's some variability that's happening. So let's take a look at our song, because we have to be able to say what's happening in context, okay? So what we say is, in this case, if you sampled many times, so if you had many different collections of data, then I'd expect that slope of the relationship between age and weight to vary about, oh, I said that the standard deviation of the slope was 0.25 right there. Okay, so I'd expect the slope to vary about 0.25 pounds per year on average. Okay, so we got to kind of remember that saying. So slope's going to vary because you're going to sample many times. It's going to vary about that much on average because it's a standard deviation. So here's my song. Slope varies. It's the standard deviation of the slope you need to know. Slope varies. It's the standard deviation of the slope you need to know. Here goes to the really important part. If you sample many times, I'd expect the slope you find of the relation between x and y to vary this much on average over time. Okay, so that's going to go here. See, look, if you sample many times, I'd expect the slope of the relation between age and weight to vary about 0.25 pounds on average over time. Okay, so here is the real song. Here we go. You get to hear it. Slope varies. It's the standard deviation of the slope you need to know. Slope varies. It's the standard deviation of the slope you need to know. Okay, here we go. Gotta get ready for this part. Here we go. If you sample many times, I'd expect the slope you find of the relation between x and y to vary this much on average over time. If you sample many times, I'd expect the slope you find of the relation between x and y to vary this much on average over time. Okay, there it is. Okay, there is that one. Now, we'll get to that standard deviation of residuals here in just a second. So, let's move on. Here we go, standard deviation of the residuals. Okay, remember, that's that average distance that all of those actual data points are from what they were predicted to become. So look here, standard deviation of the residuals is the average distance the actual values are away from what they are predicted to be. So this is so interesting. Watch this visualization. We can kind of imagine. So you don't have these lines drawn in here, but I want you to draw them in there. So we can imagine kind of like this is a residual plot, okay? So here, is your prediction line, okay? So there is our prediction line. So that's what the data is predicted to be. And so then it's the normal model. Looky here. Here is the values that are within one standard deviation of what they were predicted to be. Here is the values that were within 2 standard deviations of what they were predicted to be, and then 3 standard deviations. Well, guess what? About 68% of the data falls within 1 standard deviation of what it was predicted to be, and 95% for 2 standard deviations and 99.7. Because see, look, if you kind of turn your head side, this is what's happening is that mean is the prediction line. So this is like a mound of kind of like these 3-dimensional normal models that are that 68, 95, 99.7 away from that prediction line. Okay, so that's what's happening. So here we can see that I've got, what did I say? The standard deviation of these residuals was 3 pounds. So I drew a line at 3 pounds, and then I did it again at 6 pounds, and then I drew a line at 9 pounds. Okay, so 1, 2, and 3 standard deviations away from the middle. Well, let's take a look at our song for those. Oh, here's another interesting visual I had. I thought this was great. So here, this was so interesting. This was a residual plot. Look at this residual plot. So here was the prediction line. Okay, so what it's predicted to be the mean. And then you can see all the data on this around it. Well, look, here was a histogram that was made. So this is actual events of what happened, the actual data. And look, it's fairly symmetric, somewhat symmetric and unimodal. And so that data was, like 1, 2, and 3 standard deviations away from the mean. So the average, okay, so here's our song. Standard deviation of the residuals. So here's the meat of this song, the definition. Here we go. The average amount that the actual y, the actual y value point, varies from what's predicted to become. Varies from the predicted y. Okay, so that standard deviation of residuals is that average amount that the actual y's, the actual y values, actual y value point, varies from what's predicted to become. Varies from the predicted y. Okay, all right, so let's listen to that one. Here we go. This is actually not one of my favorites because it sounds so stilted. Standard deviation. Standard deviation of residuals. Average amount that the actual y value point varies from what's predicted to become. Varies from the predicted y. Standard deviation. Standard deviation of residuals. Average amount that the actual y value point varies from what's predicted to become. Varies from the predicted y. Okay, so there we go. All right, so there is that saying that you need to remember. Moving on. All right, so here is, let's practice this, okay? So here we go. Here we have got this computer printout here. So interpret the standard deviation of the slope in context, okay? So this is, we already had identified that. Standard deviation of the slope, that was here. Okay, so if you sample many times, I'd expect the slope you find. So if I sample many times, I'd expect the slope you find uh, of the relation between starting salary and college GPA to vary about 0.9 or 3953. And I don't know what this is, like points per $1,000 or $100,000 per. It's got to be the GPA, let's see, is the X. So it's got to be. So anyway, so whatever the units are, let me see what I had put on my key. I maybe thought about it more when I did that key. Okay, so if you sample many times, I'd expect the slope of the relation between that starting salary and GPA to vary about this much dollars per point or dollars per GPA point, whatever, on average. Oh, on average. Yikesies, okay? Because that's the average amount that they vary. Okay, now let's do the standard deviation of the residuals right here. And so that's the average amount that the actual, what's the y? What would be the y? Well, GPA is the X, so actual. So we're going to say the average amount that the actual starting salary point, varies from the predicted starting salary. Okay, so that's what I'm talking about is the Y's. So the average amount that the actual starting salary varies from the predicted starting salary is 0.53632, whatever the dollars are, however, whatever the units are. Okay. All right, here's the next one. Stop the video, see if you can't do it yourself. Price of the home per square foot. All right, let's come back here and let's check them. Here we go. So our standard deviation of the slope was that. So if you sample many times, I'd expect the slope you find of the relation between price of home and square feet to vary about this much dollars per square feet on average over time. You know what? Because it's y's over x's, so that's why I knew it was the y's were the price and the square feet were the x's. So y's per x's on average over time. Okay, now standard deviation of the slope. Standard deviation or residuals. Standard deviation of residuals. The average amount that the actual price of the home. The actual price of the home varies from the predicted price of the home. Varies from the predicted price of the home is 41.33. So what happens is, you say like, okay, one standard deviation is 41.33. So if your house is like what's two of those? 82.66. If your house is more than $82.66 away from what it was predicted to be, then there's something going on. Your house is probably like if it's way too low or way too high. It's not really meshing with market value. Okay, and I've worked with an appraiser, and this is so much what the statistical software is that I work with him in the summers on. Is we talk about, okay, well, because he does evaluations, he does the things where he goes and he evaluates your home for home loans and all those kinds of things. Well, he has to see, is it in line with the prediction model for that area or for that type of home? Okay, so there is that. I think that's the end of that topic. And then we just have this one last topic. So I will see you in the next video to do our third topic.